now.
Almost off the flag.
I hope.
He hit the flag at least 20 times last year.
No, but he made it into the thing. I like
Separable?
20 separate
Is that how you spell it?
That's 20 last year.
Rival districts.
I think it's such a good thing
For
this is
hope?
happening tomorrow. Like, I don't think we can take any more days. Seriously.
Woo! Sorry about that, Hope. Didn't mean to make you nauseous.
Fireballs and posters.
Hey, James. Throw it.
Yeah, for Hope, Zach found one of his posters in the recycling bin for his district thing, so that's why he's all in a tither.
Right, like if there's one person left in the barracks, you use that table.
I just picture it as
How do you zoom? Is it the right arrow?
No,
it's the plus sign.
Oh. Oh,
the
interesting.
best video we've had so far.
Oh yeah, it's gonna be real good.
That's gonna be demoted. Back.
And I can sit up here forever.
So here we go. Alright, this is called solving separable differential equations. Sounds really fancy. But basically a separable differential equation. It's above. Like I forgot to write it, so I put it above. It's like I don't know, how do you spell separable?
Terrible.
This is not a spelling bee.
Does it separate?
Separate. Can you draw an arrow where that is actually?
Here, where's the carrot?
Yeah.
Actually, just erase it.
Here's the comma. Here's the top.
Why is there a comma?
Solving.
Oh, well that explains it. I knew separable solving differential equations didn't make sense.
Solving, in quotes, means figuring out what y equals. This topic frustrates me to no end.
Uh-oh.
Because it is so easy. Jimmy was just looking at my zipper. Is it down?
What?
We'll rewind the camera and see.
You were really like, you just looked down and I was like, oh my god, I just went to the bathroom and I had to make sure that it was.
This is my favorite class.
Jim, we're gonna watch your
He wasn't really, he just looked down and I thought, oh god. He wasn't looking down really, I just...
James.
Stop it.
Can we watch your shoes real quick? I think she should see your shoes. Pretty nice. Right, Hope?
Okay. The reason why this topic is frustrating is because it's very easy, but people still find ways to screw it up, and it's annoying. It very often turns up as an open-ended question, especially for you guys on your midterm, because your midterm is basically like the AB exam, so it often will show up as an AB question. And the BC test is usually part of a BC question. So, when you see something like this, it should spark to you. It's a differential equation. There's a whole college class, Calc 4 is actually called differential equations. That's what the title of Calc 4 is. And a differential equation is this. It's when you have a derivative equals something, and that's just called a differential equation. Solving it means finding out what y equals. Okay, so I'm trying to figure out what was y before the derivative of y with respect to x equaled x over y. To do this, there's specific steps you have to take, and if you don't take them all, you get it wrong.
You can't just divide x by
No.
derivative. It seems like that would be one.
No.
Cross states.
Alright, the first thing you have to do, and when this is an open-ended question, if you don't do all their little steps, even if it doesn't say show the work, they will not give you credit for it. When you see the scoring rubrics for some of these, it'll say, say this particular problem was like 5 points. It'll say 0 out of 5 if it didn't separate variables, like literally no points, even if you knew what you were doing. Separating the variables just means get the y's and the dy's on one side and get the x's and the dx's on the other. So I'll cross multiply, so we'll have y dy equals x dx. So you'll just be doing some algebra stuff so that you have all of your variables together. next thing you're going to do is you're going to integrate both sides. Okay, so mathematically, what you do to one, you can do to the other. So we're going to integrate both sides. And the way it's written now, I have like two separate kind of integration problems. On the left, what's the integral of y with respect to y? And on the right, what's the integral of x with respect to x? So the integral of y is, from our power rules and stuff, we add 1 to the power and put it over that new power. So it's y squared over 2. Technically, I have a plus c. I'm going to address that in a second.
No.
Equals on the other side, the integral of x with respect to x is x squared over 2 plus c. But this is like c sub 1 and this is c sub 2 because they're different c's technically. You don't have to worry about keeping track of all of your c's. You only have to put them once and call it regular c. Because the idea is, if this was c sub 1 and this was c sub 2 and I subtract c sub 1 from both sides, I end up with c sub 3, a brand new constant. So it doesn't matter that you don't need to have them on both sides. You're just going to put it on the one side. And since we're trying to solve for y, we're going to put it on the side that doesn't have the y.
Okay.
The third step would be actually plug in any initial conditions, which we don't have here, but sometimes you will. If you have, we'll do a second problem that has initial conditions. Initial conditions might say, in your original function, when x equals 3, y is 6. So then we would plug in 3 for x and 6 for y, and we find out what c actually is. If they don't give you initial conditions, you can't find c, so you just have to leave it as c. And then the fourth thing is solve for y. Now, this gets a little weird also. If I'm going to solve for y, I would multiply both sides by 2. So y squared would equal x squared plus 2c. But what? 2 times c is really just another constant. So I like to write it as c. If you had an initial condition, we would have found c by now, and we would have put c back in. And then you'd be specific. But if I don't have an initial condition, I'm just going to leave c. Whenever I multiply it by another constant, I just leave it as c, because we don't know what it is anyway. And then y is going to equal the plus or minus square root of x squared plus c.
Just ignore c and just tack it on at the.
Yeah.
You can't totally tack it on at the end, because look, it's underneath the square root.
Oh, no,
Tack it on
right before you solve it.
Yeah. Yeah. Unless you have an initial condition. So let's do one. I have a home. This is good.
Let's just do the homework now, yeah.
Let's do it together because
No, we won't do it.
I have a second problem that's part of the notes, but this just follows it so well. There's no reason to save it for later, so that you actually see what a problem's going to look like.
How was your week?
I violated one of my very personal, strong beliefs.
Oh, okay.
No.
You did lots of drugs.
No.
You cheated on your husband.
No.
Hope this is what she handed out.
Oh,
So, yep.
rooting for the Mets. You went out for ladies' night.
I put up my Christmas lights before Thanksgiving.
Oh my God.
That's
What? Shoot him right. Hitler has them all.
I didn't like them though. So, okay.
All these awful things. What about Thanksgiving? What happened to Thanksgiving?
It was 65 degrees. What do you want me to do?
It was not Thanksgiving.
My Christmas tree's up.
No.
Is it a? It's not a real though.
No, it's not, of course it's not real, but it's up. And it's delightful.
You know?
You have a train going around.
Never mind.
No, my cat sits on it. She enjoys it.
She sits on it?
No, we have this little rug underneath that has like pictures and stuff. She loves it.
Mm.
And she clops right underneath the tree.
My cat drinks like the sappy water.
Oh, yum.
I know. It's gotta not be good.
Why
And then
not?
vomits.
It's probably like sugar water.
Maybe.
Probably tastes good.
Doesn't bother me. I barely tolerate my cat.
Wait, did you remember Christmas lights? Oh wait, the camera.
Did I what?
Do all that stuff.
No, I didn't do all that stuff. Alright, so here's a typical question. And just if you don't read it carefully, like every question has stuff nuanced in it that has to be read properly or you don't get what they're saying. Let f be a function with f of 1 equals 4 such that for all points x, y on the graph of f, the slope is given by, keyword, that means the derivative
Oh, God.
is given by 3x squared plus 1 over 2y. Okay, so they're being specific. They're telling you this is the slope. If you don't pick that up, you'll get the whole thing. Okay, the slope is given by that. We'll do all the parts because why not?
Yeah.
Part A, find the slope of the graph of f at the point where x equals 1. Well, I might go, oh no, I don't know what to plug in for y if x equals 1, but hark. What else did I tell you? 4.
Yay!
Give you this for a reason. F of 1 equals 4, so when x equals 1, y is 4. So part A is just plugging in this stuff into the derivative. If you didn't realize that they said the slope was given by this, you would have probably taken the derivative of it and plugged in x and y. And that would have been wrong. So that is the slope. So when they want you to find the slope, plug in 1 and 4. So it's 1/2, right? Okay, part B. This is number 4, so I don't think this is a calculator question, just FYI. I'm not sure in 1998 if it followed the same rules as it does for us. Usually if it's number 4, 5, or 6, it's a no calculator question. So this is number 4. Part B, write an equation for the line tangent to the graph of f at x equals 1 and use it to approximate f of 1.2. Okay?
And why is that decimal?
What's that?
Decimal is
No. Alright, write an equation for a tangent line to the graph at x equals 1. Let's do that first. If I want to write a tangent line, what 2 things do I need? A slope and a point. Well, the point is when x equals 1. What's the y that goes with that? 4. So there's my point. They're telling me x is 1, so y is 4. And what's the slope at that point? 1/2. I already found it. So this is again one of those, like, if you know how to read the question, it's not hard. The tangent line then is y minus 4 equals 1/2 times x minus 1. There's my equation of the tangent line. Second part of the question says use it to approximate f of 1.2. Okay. Let me make some sense of this. So there's some curve, right? We don't know what it is. Y equals something. And its derivative is this. And that curve can be anything. But I do know at 1, it's got a point at 4. So it's doing whatever and it's doing whatever. Okay? Well, the tangent line at x equals 1 is this. I could have this totally drawn wrong, but a tangent line looks something like that, whatever. The reason why they want you to approximate 1.2 using the tangent line is 1.2 is so close to 1 that the tangent line value at 1.2 should be really, really close to the actual value of 1.2 of the curve. Because like the curve, say it goes like this, I'm going to try to like zoom in on this. Whatever. If I find the tangent line at 1.2, it's not quite the same as the value of the function at 1.2, but they're going to be really, really close. You know what I mean? The further I get away from 1, the less I can rely on the tangent line to tell me what the value of the function is at any point. Because the further I am from this point, the more the tangent line and the curve differ. But if I'm really close to this point, the value at the tangent line and the value at the curve are almost the same. They're really, really, really close. So sometimes a question will ask you, what is f of 1.2? Well, I don't know what y equals, so I can't plug 1.2 into y to figure that out. But I can plug 1.2 into the tangent line that went through the point 1. And since 1.2 is so close to that, it's like a pretty good approximate for f of 1.2. Do you get that? It's kind of a crazy concept, but you're going to see it come up more than once. So yeah, that's why they want you to do this. So let's do it. So if I reduce this a little bit, 1/2 x minus 1/2 plus 4, is this 3 1/2? I don't even know. So if I plug in 1.2, we're supposed to use no calculator, although I can't imagine you're supposed to.
Why wouldn't you just put it in?
Oh. So I'm going to write it here then. Plug in x equals 1.2. So y minus 4 equals 1/2 times 1.2 minus 1 is 0.8. So that's 8/10. So that's like what, 4/5?
You just said 0.2.
Oh. I was thinking 0.2.
You shouldn't do work today. You're not great.
I hope you're not writing in pen.
Sorry.
Jesus.
You know what? So 0.2 is 1/5 times 1/2 is 1/10 plus 4. Is it 4 and 1/10? 4.2? Okay, I know I heard you the first time.
4.1.
Oh
my God.
I did say 1/10, didn't I? Sorry. It's so funny. My husband makes fun of me all the time that like I can do crazy math, and when it comes to like mental math, forget it. Terrible. Okay. So anyway, who cares? I'm so confident no one cares. So 4.1 is the tangent line approximation for y equals 1. Or the x value of 1.2. Here's where it matters. Let's go to part C. So we haven't even done yet what we came here to do, which was solve the separable differential equation. Part C says, find f of x. So find y, is what it's saying. By solving the separable differential equation, blah, 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 with the initial condition f of 1 equals 4. Now we got to go into our little thing. So the first thing we got to do is separate the variables. So I'm going to cross multiply 2y dy equals 3x squared plus 1 dx. Next thing we do is integrate both sides. The integral of 2y is going to be what? Y squared. Okay, it'll be 2y squared over 2. So y squared. I'm not going to put my plus c there, I'll put it on the other side. This one will be x to the third, all over 3, but the 3's cancel. Plus, what's the integral of 1? X. I know what variable to use because I'm with respect to x on this side. That's why that dx is important. It tells me what variable I'm talking about. Plus c. Here's where we now plug in our initial condition to find c. So there's a couple ways to do this, but this is the way I think is the best. Don't solve for y first and then plug in. It's a lot easier to make mistakes that way. So from right here, I'm going to plug in 1, 4, and I'm going to find c. So 16 is going to equal 2 plus c, maybe. So c is going to be 14. I'm going to put that c back in exactly where I came off. Like I don't want, Suyan, you said like put c at the end. Don't, like go put c back in now before you ever solve for y. It just prevents mistakes later. So y equals the positive or negative square root of x to the third plus x plus 14. Good.
I just don't understand what exactly it means when we solve the differential equation.
Like, if I go take the derivative of this, I'm get this. Now, like, not really, because because like, if I take the derivative of this, it's going to have all x's. That has a y, but I could algebraically manipulate my answer to get back to that.
So what's the point of solving?
Because I just found out, like, if the derivative is something like that, its original function was this. So, like, if I know an equation for the rate of change of something, I can find out its original. Is the point?
We're supposed to do D without a calculator?
No, when I just looked at it, I think it must have been a calculator problem. So part D is really important because it pulls, like, the whole concept together. Part D says, now use my solution from part C to find f of 1.2. So now that y equals the square root of x to the third plus x plus 14, I'm going to plug in 1.2. So I don't think they expect you to do those calculations without a calculator. Does someone have a calculator out? They can do this real fast. Someone does.
bet it's gonna be near what you want.
I bet it is too. That's what's so exciting.
Not really near.
Is to me. It is plus or minus. We're gonna look at the positive value. I don't know.
4.11.
Oh,
It's not that close.
Oh my gosh.
so that means it was actually increased.
It does.
F was increased.
And I hate to even say it, Corey, but that's a brilliant connection to make. So, what you should pick up from all of this, like in conclusion, is that if this was your curve, again, I have no idea what it looks like. We just know that at 1, 4, it's got a point, and whatever. If its tangent line approximation at 1.2 had us at 4.1, but its actual value is 4.11, then it's just the curve is a little bit smidge above the tangent line. So the curve from 1 to at least 1.2 has to be increasing so that it comes up a little bit away from the tangent line. Do you see the connection they're trying to make? There's two things. Number one, you can use tangent lines to approximate values of a function as long as you find that tangent line really close to the point you're looking for. So like, I was looking for 1.2 and I found the tangent line at 1, that was close enough. And number two, this is how you solve a separable differential equation. You separate the variables, you integrate both sides. Before you go any further, plug in the stuff for C, put C back in, and then go ahead and solve for Y. Zach, stop spelling dirty words on your calculator. That's how it sounds. Alright, get it?
So, are we done?
I'd like to do one more.
No.
It's different though.
That's different.
Son, can you do this? It's distracting me. Okay.
The video's distracting you?
Yeah, I focus more on the filming and the notes. I know how you feel.
Double prime.
I don't pay attention to you. There's definitely people that I care about their learning more than others, for sure.
Oh, I
And it's not us in the back.
Shut up.
Who was your most favorite and least favorite person? That question.
Who's my most favorite and least favorite?
Hopefully you can see that.
I said most was Monica and least is Corey, probably.
Where do I fall on that scale?
That's fair.
No thanks.
I mean, honestly, I go home each night and I renumber it, but that's where it
Pretty
usually.
much says Corey at the bottom.
Yeah, top and bottom are like pretty set, and then I just renumber. Alright, so hopefully you're starting to get this idea of derivatives. Multiple derivatives are like a ladder in that the original steps down to the first steps down to the second, and so on and so on. We can also step back up. So if I have a problem like this, and I'm given the second derivative and the first and the original, and I want to find what f of x is, I'm going to start at the bottom. Because if the second derivative of x equals 4, any idea what I would want to do with that? Yeah, I want to integrate both sides. Because I want to try to step up to the next level. And what I can do is the integral of f double prime is going to be f single prime. Because the derivative of f prime is f double prime. So it works, like I can go back and forth both ways. What's the integral of 4? 4x plus c. And what I can do now is I can go plug in some values to find that c. I don't want to take a second integral of that because then I'm going to have like crazy c's going on.
But they all cancel out to be 1 c.
No, but I wouldn't. Like if I integrate this, I'm going to have, this is going to be cx, and there's going to be another c.
Yeah.
It's going to be crazy. So I want to say, all right, this is 6 when x is 3. So c equals -1. I want to go put that back in. So the first derivative of x equals 4x minus 1.
Wait a second.
How does that?
That doesn't work.
No.
What did I do? Oh, 12.
Minus 12.
What? B.
I'm telling you, mental math is like, don't even get me started.
C equals -. Why are you so like?
I am so bad at mental math. It's terrible.
Why?
Because I don't stop and think about it. I just like,
That top thing is fine. That's
Yep.
I added the 4 and the 3 and I got 7. That's what I did. That's what I did. No, that is 6 minus,
That's a C.
it's a 6.
That's a 6.
I don't know, it's just ridiculous. Whatever. Every time I see the color pink, I say yellow. And every time I see yellow, I say pink. So there's something in my brain that doesn't connect. I'm dead serious.
There's quite a lot of things actually.
Just saying. Okay, so then we're going to do it again.
Back to the problem.
Like when you say Corey, you mean Monica.
When I say what? Corey, what?
When you say Corey, you mean Monica.
Right.
And Monica means Corey. Thanks, Eric. Sit down for me. Gotcha.
So the integral of the derivative of f is f. And the integral of 4x minus 6 will be 2x squared minus 6x plus c. Can someone confirm?
Yeah.
I have no confidence right now. My multiplying ability. So I'll plug in again, but now for f. Why don't I do this in a couple steps? You know what? Whatever. I don't care. I get C and then I put C back in.
That's not hard. This isn't that hard.
Yeah, this is
I
easy.
feel like I'm gonna test this in math.
I'm just telling you, I don't know what it is about the other things. People just get them wrong. I should give you a homework problem.
You should.
Just one.
Yeah, I'll just give you one.
Come on, man. I need to buy the
Tomorrow's
coffee.
We're training for
Hey.
Hunger Games.
You just haven't.
I gotta go get big. Naked. And naked. What's Monica?
Nobody
wants
wants
to
to
do
do
it.
it. We don't talk about that.
Alright. No. They're gonna win.
Oh, sorry, it's okay. Thanks.
What? Yeah. Where were you? Oh my god. Well, you know
Wait, did you do?
It's gonna be really hard. Yo, Mike.
Monica didn't know your name.
Just cut some jeans really short. That's I got a red shoes.
No, I didn't hear that.
How did I?
No, she's
It's Mike.
What's the problem?
Back to homework.